Three-phase circuit.
And welcome to another episode on Apply Electricity with King Solomon and Because the Brown. Okay, so today our topic for today is three-phase circuit. So we'll be dealing with three-phase circuit. All along, all what we've been doing is single phase. So today we are zooming into the three phase. So before we enter into three phase, there are some basic points I want us to make before we can enter into the real deal of the three phase. So a single phase generator produces a single sinusoidal voltage. So that is basically what we do in single phase. You will see that there is one generator or a source of supply that will supply to the circuit, and all what we'll be talking about will be dependent on that single phase generator. But since we are going to talk about three phase, what does three phase generator do? Three phase generator, on the other hand, produces three equal voltages which are out of phase with one another by 120 degrees. So you get three windings or three connections coming together at a point or joined to each other based on the type of connection you have. But the most important thing between them is that each phase differs from the other by an angle of 120. A three-phase system is a power supply system consisting of three voltages which are 120 degrees out of phase with one another. Okay, one may ask, why three-phase? Three-phase because it has some advantages over the single phase. And some of these advantages are it is relatively cheaper as compared to a single phase generator. So devices like three phase motors, three phase generators are relatively cheaper as compared to the single phase. 2. The three phase transmission lines deliver more power for a given weight and cost. So if you give, the reason why they say it gives more power is that three phases will be doing, this is one phase, and each phase will be working as individual single phase. At the end, their power is going to be joined together. That is why they are saying that it delivers more power at a given weight and cost. So the cost and weight that will give to a single phase, that maybe it will give you a certain amount of watt of power. When you give that same weight and cost to three phase, you will get more power than the one in single phase. And the last one, three phase transmission lines voltage regulation is inherently better. So if you want to regulate the transmission lines in three phase, it is slightly better than regulating the transmission lines in single phase. Okay, so basically, when we come to three phase, there are two main connections of three phase winding. So the first connection is the star. So we have the star connection. With the star connection, you see the winding will be like this. So basically, this is a star connection. The three phases come together at a point. So they all meet at this point. And this one will be your VA, this one will be your VB, and this one will be your VC. So when you have this kind of connection, we call it star connection. And in the star connection, there are some things that you must take note of. Always when you are drawing these phasor diagrams or this phasor diagram to represent three phase, you choose a reference. You can choose x-axis as your reference or the positive y as your reference. So choosing this as my reference, I would say that this is Vm sine omega t. So if this is my Vm sine omega t, I know the angle between this and this is 120. 120. 120. So if I want to find Vc, and Vc is in anti-clockwise to A, always the phasor diagrams when you draw, they should be in reading the angle, going anti-clockwise is positive and going clockwise is negative. So coming anti-clockwise 120, this one is going to give us Vm sine omega t plus 120 degrees. And coming clockwise 120, we are going to get Vb is equal to Vm sine omega t minus 120. So sometimes in phases, they can simply draw this. And they will tell you that VA is equal to V angle 0. And VB is equal to V angle minus 120. And VC will be equal to V angle 120. So basically, this is the star connection. But under star connection, when they give you a question or when you are going to deal with a real life problem, depending on the connection that the three phase is having, you must have some conditions that applies to it before you can solve that problem. So in star connection, the first condition, the condition that you must know is that the phase current and the line current are the same. Under star connection, the phase current and the line current are the same. Somebody may ask, what is phase current? Phase current is just the current that goes through a particular winding or a particular impedance or a particular load. That is phase current. But line current is the current that is coming directly from the supply. So in star connection, the phase current, the current that is going through this winding, is the same current that came from the main source. And the same current is going to flow through the whole circuit. That is the good part of the star connection. But what about the phase voltage? What relationship does phase voltage and line voltage also have in star connection? In star connection, the phase voltage is not equal to the line voltage. And to find that, the relationship between them, we use this and that. So we want to find VAB. If you want to find VAB, let's clean this side. So VAB. Unlike vectors that if you have AB, the position vector will tell you it is OB minus OA. In electricity, this doesn't hold. So if you come and they've given you VAB, it means it is VA minus VB. It doesn't work like vectors. So when you come here, what is our VA? Our VA is given by V angle 0 minus, what is our VB? It is given as V angle minus 120. What is going to happen with this? We can factorize V out. Then you'll be left with 1 angle 0 minus 1 angle minus 120. So from the complex math we learned, one can say that that is given by 1 angle 0 will always give you 1. So your V will still be standing outside. But this one is going to give us minus bracket cos of minus 120 plus sine of minus 120. But the sign, it has a J. Why J? In complex maths or in algebra, they told you that the imaginary is I. But when you come to electricity, imaginary, if you use I stand for current. So we use J to represent the imaginary. So with that in mind, now let's continue. You have V, and this is going to give you 1 minus cos of 120 is negative 1 over 2. And sine of minus 120 is minus root of 3 onto J. Now remember, this minus affects everything there. So we are going to get V being equal to 1 minus minus half will give us 3 on 2. And we are going to get negative negative, which is plus J root 3 on 2. So basically, this VAB refers to the line voltage. So this one, when you point only this on the calculator, when you go to complex number, if you convert this to the normal thing that we know, we are going to get root of 3 angle 30 of V. But we are not interested in the phase. So it means our line voltage is going to be equal to root of 3 of our phase voltage. So that simply means that if we have a star connection, the phase current and the line current are the same. But our phase voltage is not the same as the line voltage. The line voltage is root 3 times the phase voltage. So basically that is what we have in star connection. And I told you there are 2 connections over here. So in any question that we are going to meet under 3 phase, it's either they will tell you it's a star connected or delta connection. So if it's a star connected, you must keep these 2 things in mind. Basically, those are the 2 things we are going to use. But if it is delta, let's see what we are going to do in delta connection. So the next one is delta connection. Delta connection is more or less like something like this. Already we've treated delta star, so we know how star is and how delta is. So this one can represent our V, which is V at angle of 0. But in delta connection, like we said in star connection, phase current is equal to line current in star connection. But in delta connection, phase voltage is equal to line voltage. So you see, if you don't take care, it will contradict with what you know. In star, line voltage is equal to root 3 phase voltage. But in delta, phase voltage is equal to line voltage. But if I go through the for the current, I'll end up getting line current is equal to root of 3 phase current. If I go through the derivation, I'll come and see that the second condition that I need for delta connection is that the line current will be equal to root 3 the phase current. So basically, this is the understanding of 3-phase system.